Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4D in Section 4, and now we're going to present an analysis of relationship between material properties and engineering performance in industrial application.
Assalamualaikum, my name is Akmal. For introduction, hook the audience by establishing why material selection is the foundation of engineering. Every great engineering achievement, from the tallest bridges to the most advanced aircraft, begin with a single critical decision: choosing the right material. Material properties are not just abstract data, they are the fundamental factors that dictate how an engineering system performs. For instance, a bridge requires a high strength steel to support massive loads. An aircraft needs the lightweight nature of aluminium to maximize efficiency. And our electrical system rely on the superior conductivity of copper. Throughout history, we have evolved from using basic materials like wood and bronze to advanced metal like steel, aluminum, and copper. In this video, we will explore the direct relationship between material properties and engineering performance and see what happens when the selection goes wrong.
Assalamualaikum. My name is Muhammad Maifki bin Azlan, grade number 3, BD250147. Today, I will be discussing this steel, which is a material known for its high strength and toughness. As shown in this table, steel has high tensile strength and high toughness, making it ideal for load-bearing structures. Its ductility is medium, allowing it to bend before breaking, providing warning sign of failure. However, steel has high density, making it heavy and low corrosion resistant, requiring protective coating against rust. A perfect application example is bridge. Still high tensile strength allow bridge to support massive loads from vehicle and trains. Its toughness ensure the structure can absorb shock during earthquake or extreme weather. Engineers use protective coating to overcome corrosion, ensuring bridge maintain integrity for decades. In summary, steel strength and toughness make it the undisputed choice for heavy load application like bridge and buildings. Now, let's discuss about aluminium, a material prized for being lightweight and corrosion resistant. As shown here, aluminium has low density, about 3 times lighter than steel. It has high corrosion resistance thanks to its natural oxide layer. Its strength to weight ratio is high, to its tensile strength is only medium. Thermal conductivity is medium, useful for cooling application, and ductility range from medium to high for forming complex shapes. In bridge, aluminium is used for movable component, where reduced weight make mechanical operation easier, and for the pedestrian bridge and railings. More broadly, aluminium dominates aerospace for fuselage and wings, and automotive for body panel, where weight reduction directly improve fuel efficiency. In summary, aluminium lightweight and corrosion resistant make it essential where reducing weight is the priority.
Assalamualaikum, my name is Fadil Jasmine bin Jasman and my metric number is BD250131, and I will explain about properties in copper. First, copper have a very high electrical and thermal conductivity, which means copper can transfer heat and electricity very well without losing much energy. Other than that, copper has a high ductility, which means copper can be turned into a very thin wire without breaking apart. Even though copper has a medium corrosion resistance, but it still can perform well in many environments. And lastly, copper has a high density and melting point, which means copper can perform in a high temperature environment when operating. Overall, copper is very essential in electrical, electronic, and thermal engineering.
For comparison, clearly contrast the three main materials studied to highlight their unique strength and weakness. To truly understand material selection, we need to compare how steel, aluminum, and copper stack up against each other across key properties. For density, if you need a heavy-duty structure, steel's high density provides the necessary mass and robustness. However, for applications where weight is the enemy, aluminium is the preferred choice due to its low density. For strength, steel is our go-to for high tensile strength, making it ideal for structural support. Aluminium and copper offer moderate tensile strength, shifting the focus of their applications elsewhere. Conductivity. For conductivity, this is where copper stands alone with very high electrical and thermal conductivity. It is the standard for power transmission and electronics. In comparison, steel has very low conductivity, making it unsuitable for those specific tasks. For lastly, corrosion resistance. Aluminium excels here with high resistance, while steel, unfortunately, has low resistance, meaning it often requires protective coatings. Ultimately, while steel is cost-effective for structural work and copper is unbeatable for conductivity, balancing this property like aluminium does with its strength to weight ratio is what defines successfully engineering.
Assalamualaikum. My name is Muhammad Taufiq Hakimi bin Jamil with matrix number DD250120. This slide shows how material properties affect engineering performance. In engineering, material selection is very important because different materials have different properties. For example, steel has high tensile strength. Because of this, steel can support heavy loads and is widely used in building, bridge and vehicle structure. Aluminium has low density, which means it is lightweight. A lighter material can reduce a total weight of a system and improve fuel efficiency, especially in aircraft and transportation. While copper has very high electrical conductivity, this allows electricity to flow more efficiently with less energy loss, making copper suitable for electrical and electronic systems. So we can see that material properties directly affect the performance of an engineering product. This slide shows real example of how material properties are used in engineering application. For steels, its high tensile strength allows structure to carry heavy load safely. That is why steel is commonly used in construction and automotive industries. For aluminium, its low density helps reduce weight while maintaining good performance. Because of this, aluminium is widely used in aircraft structure and transportation system. For copper, its high conductivity makes it very effective for transmitting electricity and heat. Therefore, copper is commonly used in wiring, circuit board and other electrical components. In conclusion, when the right material is selected for the right applications, the system can perform efficiently, safely and as intended.
Hi, my name is Muhammad Fahrusnan bin Ashraf, number matrix DD250088. So today, we're going to talk about the consequence of wrong material selection. Let's look at our 4 real-world scenario that we're picking up. The first scenario is bridge. People use aluminium instead of steels. The mismatch property is low strength, and the consequence is unsafe and fast fatigue. The second scenario is electrical wiring. People use steel instead of copper, and the mismatch property is very low conductivity, and the consequence is energy loss and fire risk. The third scenario is aircraft structure. People use steel instead of aluminium. The mismatch property is high density, and the consequence is heavy and high fuel cost. The last scenario is heat exchanger. People use steel instead of copper. The mismatch property is low thermal conductivity, and the consequence is overheating.
Okay, my name is Muhammad Ikram Hakimi bin Officer, matric DD250074. Okay, I will explain about relationship across multiple requirements. Okay, for example, one we have automotive industry, which is car. Okay, for component we have four component. We have crash zone, body panels, electrical wiring, and wheels. And for material, for crash zone, we have a high strength steel, And material for body panel, we use aluminium. Electrical wiring, have a copper, and the wheels, we have aluminium alloy. And property use for crash zone, we have very high toughness. And the performance goal for crash zone is passenger protection. And the property use for body panel is very light. And the performance goal is full efficiency. And for the electrical wiring, for the property use is excellent conductivity, and for the performance goals is reliable power. And the last one is a wheel. For property use is very good strength to weight, and the performance goals better handling. Okay, for the example two, we have the aerospace industry, which is a aeroplane. Okay, for the component, we have seven component, which is the fuselage body, wing structure, landing gear, jet engine blades, electrical wiring, rivet and fasteners, and window frames. And for the fuselage, we have used material aluminum alloy. Property use very light, and the performance goes reduce weight, lower fuel consumption. And for the component wing structure, we the material used is aluminum alloy. Property used is moderate strength plus very light, and the performance goal is too strong enough yet lightweight. Okay, for the landing gear, is high strength steel, and property goal very high toughness and absorb heavy impact during landing. And the material for jet engine blades is steel alloy, and very height resistant, and for the performance goals is withstand extreme temperature. For the electric wiring, we have copper. We use the material used is copper, and the excellent conductivity, because it's excellent conductivity, and the performance goal is reliable power for avionics. And for relay, the material used is steel, because it's a very high strength, and for the whole structure together securely. And the last one is a window frames. Window frames use the material used is aluminum alloy. Property used is high corrosion resistant, and the performance goals prevent rust at high altitude.
Now, let's move on to our final slide to wrap things up. We have four main takeaways from our presentation today. First, property directly determine performance. If we want a structure to perform well, we must understand its physical and chemical property first. Second, wrong material selection leads to a failure. As we saw in our example, picking the wrong material is never a minor mistake. It leads to a broken system and disaster. Third, rail application needs multiple material. No single material can do everything. A complex system like a plane or or a building require many different material working together. And finally, engineer must combine materials strategically. We do this based on property performance matching, choosing the exact right material for the exact right job to make sure everything is safe, efficient, and reliable. Thank you from us.
Sincere gratitude to our lecturer, Professor Madya and Senior Technologist Dr. Ainun Rahmawati binti Ainuddin for teaching us this course. That's all from our group. Thank you for watching.